And we're back. Hi, everyone. My name is Patrick Akil, and welcome back to the Leadership Track. Joining me all the way from Japan is Mesut Durukal. How's it going, man?
It's good.
Good.
Thanks a lot.
Good stuff. We'll get right into your talk on the evolution and future of software
Yeah.
testing. Have fun.
Thank you. And yep, I think we are ready. So, hello everyone. Greetings to all the audience. My name is Mesut Durukal, and I'm very happy and very excited to be a part of this amazing conference. And I'm a quality assurance engineer. I'm working in this field for almost 15 years. And I have worked in lots of different domains in lots of different projects. So I started working in defense industry, and then I started working with IoT devices, cloud platforms, and autonomous mobile robots. I did the warehouse automation, and eventually I'm doing the testing activities for developing mobile and web applications. So quickly overviewing all this background, what I did and what I'm doing has changed a lot. And whatever I am doing, in what ways I am doing, has also changed. But there is one thing which did not really change, and which is the motivation, or whatever we are doing, or in what ways we are doing, why we are doing all this. And the answer is, of course, the quality mindset. Whatever we are doing and in what ways we are doing, we are trying to ensure the quality in our products. But today we will a little bit talk about the evolution of software testing. So how it changed, and from which point we started, and how we modified or upgraded our processes, our workflows, and what kind of improvements we have done. We will talk about. So we will go over previously what we were doing, and then today what or how we changed them, how we improved them, and eventually what furthermore we can do, or in what other ways we can even further improve our processes. We will talk about. So maybe what we will do even more in the future, we will try to talk. So let's start with an introduction. So we are talking about some changes or updates. But why do we have to do these kind of changes? Because let's find the optimum configuration and then proceed with this, right? But it doesn't work like that. Technology is growing fast. Every day we are coming up with a new solution. There are always some new problems because the applications or the products that we are developing is changing a lot, and in the meantime, the solutions that we are applying to cope with this kind of challenges or the problems are also changing. So we have lots of different challenges in terms of testing. Like the scope is very wide. It is not very easy because the applications that we are developing are running in lots of different platforms. It is not only on mobile, but also it is on the lots of different browsers working on different operating systems, and on different browsers. Not only one of them, but we have to support the compatibility activities as well. And there are lots of different interactions and integrations between the applications. They are talking to each other, they are communicating to each other. So we have to verify and validate all these kind of interactions or the integrations between them. We have lots of interfaces to test, and we have a very limited time. This is another aspect of the scope. The quality, the time, cost, resources, all these kind of constraints are the challenges that we have to cope with. So it looks a little bit scary, and we may feel desperate. How can we deal with all these kind of challenges? Because there are lots of different problems. But these challenges were the reason, or they were the triggers which forced us to improve our processes. So if we a little bit overlook on the improvements on the quality assurance activities, we can see that they started by some simple inspection activities, and then we saw lots of different improvements. They were mostly driven by the automotive industries and the companies. Mainly, I'm living in Japan, and I can see already lots of different applications in different companies. They were driven mostly by Toyota, but by some other companies as well. So we saw the lean production approaches, or Kaizen, or some other quality improvements. And recently, we have the agile methodologies integration into our processes, and we have the IoT applications, AI platforms, and lots of different integrations. But a little bit more focusing in the software testing area, what we can see is we started by mostly manual testing. When I'm thinking about my early career, I was doing mostly manual testing in system level. And then more and more, we adopted test automation because we wanted to do the or start continuous testing because we gave up from the big releases, seasonal releases. Like again, I remember sometimes we were having some big releases. Like in 2 months, we will have a big release which will go in production, and then the next one is again in 3 months. These were seasonal releases. But now what we are doing is almost every day we are having some releases, right? We are having some candidates, and we are deciding if they are ready to go to production or not. So we are always having some commits, always have some pushes to the branches. And what we have to do is these changes do not break anything. So we have to ensure that these changes are still making the system functional. So this is the continuous testing. So to be able to perform this, it is not easy to do only by manual testing. So what we started to do is to do test automation. And eventually, we gave up from doing waterfall because we don't want to wait for too much time. And we want to collect some early feedback from the customers or the end users. So, by small iterations after each sprint, by having some MVPs, we go to the customer and collect their feedback. And then we have a minimum shippable or viable product in a very limited time. This was the agile approaches that we embraced, and eventually we had the after the continuous testing activities, we had the DevOps and CI/CD platforms, and maybe eventually more and more we started using AI algorithms in our testing approaches. So we will talk about all of these stages one by one. But one little reminder before discussing all of them, each of them in detail. It is related to the it is referred as Harper's law. I think it was initially based on some financial approaches. But what we can understand from this is improvement. No, originally it says improvement means deterioration. But what we can understand or how we can interpret this is whenever we do some improvements, then we will have some more improvement rooms, or we will have some other points which we can further improve. So this is why we are calling this continuous improvement. Improvement never ends. We can fix something or we can improve some parts of the processes that we are applying, but there will be some more and more improvement rooms. We can always try some new solutions, and we can always try some better ways to improve the efficiency, or on the other hand, maybe reduce the maintenance or reduce the resources that we are using. So this is why we try to replace our manual activities to reduce the manual efforts, to do more automated stuff, and maybe to do in a more smart way or in a more efficient way. So let's start talking about them one by one. The first transformation was the replacement of manual testing activities by the automated testing. So test automation is great. It has lots of different advantages. For example, we can do some activities thanks to automated testing, originally which we cannot do only by manual testing. For example, if I want you to send lots of different concurrent requests to the servers to test maybe resilience or the performance, or maybe the to do the endurance testing, load testing, a lot of things we cannot do manually, right? We cannot collect a lot of people and ask them to send some requests or queries to the servers. It's not feasible. So, but we can do this by automated testing, and not even only which is the things which is not possible by manual testing, but even if they are possible, we can do in a more efficient way or in a more smart way. Especially if we are talking about the repeated activities, of course, embracing automated testing is or makes more sense. But there is the other side of the medallion. Again, referring to the previous quote, if there are some improvements, there will be some other challenges that we have to cope with. So let's a little bit talk about the challenges of the automated testing. So this time we have to talk about the test reliability. When we automate test case, when we are able to execute it automatically, we have to be able to rely on the test results. What does it mean? If my test case is reporting a failure, my test case is failing when the feature is working properly, which means it is working aligned with the requirements, but my test case is failing. So I'm notified. I have to see what is the reason or the root cause of the failure. If it is a real bug, which means a bug or an issue stemming from the product, or it is a false alarm, which means it is not stemming from the product itself, but I have any issue in the test code itself. So this is the false alarm. And in this case, I will have some more maintenance effort. I will have to do the analysis to understand if this is a false alarm or a real bug. On the other hand, if the product has some issues or weaknesses or vulnerabilities, and if my test case is not capable of catching this bug, which means my test case is just passing, it means I have the silent horror case now because there is an issue, but I am not capable of, or my test case is not capable of catching this. It is not notifying me. It is just passing. It is not reporting any failure. So, which means since I am not able to catch this on time or in the early stages, I will have this issue on the later stages, maybe in production. Maybe the customers or the end users, the clients will report this. So it will be an escaped bug and it will be a prestige issue for me or for my company or for my product, for my brand. So we don't want escape bugs. We have to catch them or we want to catch them in the early stages. This is why we are encouraging early QA involvement. But the key point to do this or to be able to do is the test reliability. So they have to report me the correct results. But why can they or may they report some wrong results? Because I may have some test smells in my test automation framework. There are dozens of types of test smells, like the flakiness in the tests, one time passing, one time failing, or the fragile tests, which are started to be broken after I change the test parameters or test inputs, or maybe structural issues, maintenance issues. There are lots of different aspects of quality. So I may have any of them in my test automation framework because, again, just like developing the product code, when I'm developing the test code, I have to consider lots of different aspects of quality, not only the functionality, but also the understandability, maintainability, recoverability, lots of different non functional aspects of the quality as well. So how I can improve is maybe I should embrace some code quality improvement approaches. For example, maybe I can use the static code analysis tools. One of the most commonly known one is SonarQube, right? Maybe I can install in my servers, but otherwise I can use the some plugins working on my IDE, maybe SonarLint or some other linters. Or not only the static code analysis tools, but also I can do the peer reviews. So this is the importance of pair working and pair programming. And whenever I implement my code, I can share it to another colleague in the team and I can collect some feedback. Maybe he or she will share some points which I can do in a better way. So if we really efficiently do the code reviews, maybe we can improve the code quality in a significant context. So this is the importance of having strong quality gates. If we have any issue in the test automation framework, we should block them. If we let everything go in production, if we just merge to our main branch, then we will have some issues and we will have some risks which will appear in the later stages. So, the second transformation, after replacing manual activities with automated testing, the transformation from waterfall to agile. Again, it has lots of great advantages. We don't have to wait for too long times to go to production and see the customers' reactions or their collect their opinions. And we don't need comprehensive documentation because in agile, Working product is more important than the comprehensive documentation. These are great advantages. But again, there are some new challenges we have to cope with. Working product is more important than comprehensive documentation. That is true. But it doesn't mean that we don't need any documentation at all. Because in that case, we will have some ambiguity, right? We will, some of the points or some of the features, some of the behaviors will not be very well known or will not be very clear. For example, when I talk to everyone in the project, everyone has a basic understanding of the main functionalities or the main behaviors. But when I ask some questions regarding the corner cases or especially the negative scenarios, what we expect if the customers do a mistake while providing a test input, what is the expected situation or what is the expected result? In these kind of corner cases, there are some different answers that I get. Someone says, maybe in that case, the server should just ignore the request. Or we should respond with a, bad request code or response code. So there are lots of different misunderstanding. So what we have to do is maybe we should improve the communication and the visibility. So what we should do is maybe, or we could do, sit together with the product owners, product managers, or the development leads, and try to understand what is meant to be implemented, what the end users or the customer are expecting from this product. Otherwise, if we are really not sure about the expectancies, then we will not be able to assert the expected behaviors, and we cannot compare the actual results by or with the expected results. So this is one thing that we have to improve: the collaboration, the visibility of information, and from another perspective, in Agile, I have to start my testing activities or the preparations in the meantime, right? Because otherwise, I will be too late. If I wait for the working product, then it will be too late. I should have already started my preparations whenever they start the implementation. But if I'm not aware of what is being done in development teams, then how can I start my preparations? They should let me know what they are working on. So this is the result, or this is something that we can accomplish by a strong communication. So this is what we should improve. And if we do this in a good collaboration, because otherwise, if we are trying to ensure the quality individually by only certain group of people, we will not be achieving this. It should be a teamwork. We should define all the levels, all the scopes, all the priorities. If I try to run all the tests in system level, if I don't have any integration level or any unit level, it will be very inefficient way, right? I think one of the previous sessions was related to this test pyramid, so I will not go too much in detail, but we know the importance of this. But the key reason or the key point for achieving this is building a strong communication channel and a collaboration and building a whole teamwork. Otherwise, we will not be achieving our quality goals. And transformation number three, it is the replacement of big seasonal releases with the continuous integration and continuous deployment. So throughout this journey, we discussed a lot of novel approaches like should we shift left, should we shift right, should we test in production, or where should we left, where should we shift? And maybe the answer is we should shift everywhere, which means we should do the continuous testing. We should do both test in production, and of course, we should start our testing activities in the early stages. So now it is a great idea. It makes a lot of sense. But again and again, we will talk about the new challenges that we have to cope with. So this time, the test stability and robustness is very important. Because since I will be again and again, a lot of times execute my test cases, it should be stable and it should not be fragile. I should be able to execute the test cases on lots of different configuration. For example, I can change the browser on which I'm running the test cases, or I can change the version, or I can change the application which is under test. Like if I have lots of different web applications in the same system, just to sake of the reusability, I can dynamically generate the URLs In this way, I can execute lots of different applications with the same test code. But for this purpose, my test cases should be flexible enough and scalable enough. And not only scalability and flexibility, but also they should be robust. When I change the parameters or the configurations in which I'm running the test case, they should still give me the correct results. And for this purpose, I should, of course, do the continuous tracking, which means I have to do the continuous monitoring to see if they are sometimes failing or they are always robust. And if I have the platforms or the tools in which I can do this continuous monitoring, then I can have an understanding or I can have an idea about the robustness of the test executions. And not only the test execution, but I can do lots of different continuous monitoring activities. I can collect lots of different key metrics. Maybe those metrics would coming from the bugs. I can collect lots of different insights from the bugs, right? For example, I can analyze what type of bugs mostly I'm having, or on which module or on which component of the product the bugs are mostly raising. These kind of metrics I can collect, or I can collect some metrics from production environment. For example, the response times or the speed of the pages in my web application, or the number of requests or queries which were not responded properly by the customers. So I can collect lots of different metrics to understand how satisfied the customers are to use this product, or what kind of problems they are having. And I can again collect some insights. For example, I can observe under what conditions my application starts to be not responsive. If I get some clues, like under which conditions I expect some uh, like the situations or behaviors, which is not the ideal case, then I can take some related action items. So these monitoring activities help me a lot to collect some insights about the quality of the product. So this is one more thing or another effort that I have to think on. This continuous testing activities and the continuous quality assurance activities has a lot of advantages and benefits. But on the other hand, there are some more things, more stuff that we have to plan and we have to allocate some resources on. In this way, we can ensure the quality continuously. So, in the last part of the presentation, let's a little bit talk about how we can cope with this kind of challenges with the help or support from the machine learning algorithms, from the machines themselves. Because whatever we are talking, like which improvement we are talking about, always we see that there are some new challenges or new difficulties that somehow we have to cope with. So we always need a support because again we have a very limited resource. We are dealing with lots of different updates, right? Agile is very open for changes, and the behaviors that I'm trying to cover are changing a lot. Not only the behaviors, for example, the applications or the system that I'm testing is also changing. For example, if I'm doing the UI automation, the front end automation, I have to locate the elements on the pages. But if I'm using the class paths or the class names, or maybe any other paths like XPaths or any other traditional locator, if the layout of the page is updated or changed by the development teams, then maybe my locators will be broken. So what I have to do is I have to heal my test cases. I have to fix the broken part of the test automation or the test code, and I should continuously maintain my test automation framework. So if we find a better way or a smarter way to manage these kind of challenges, then it will help us a lot to reduce the manual efforts or the maintenance efforts. Again, one other talk was automation is still manual. So this is what I think what is meant by the talk. Even if we think that we are doing automation, there are still a lot of manual efforts. So this should be the eventual purpose. Even those kind of manual efforts, we are trying to resolve or manage or maintain thanks to some other novel approaches. So if somehow I can do self-healing test cases, even if it is broken, it should apply the relevant fix. Or even in the first place, maybe my test case should not be broken at all, even if the layout is changed or updated. So let's a little bit talk about what we can do thanks to the machine learning algorithms in lots of different software testing stages. So this is the ordinary software testing lifecycle. We start by analyzing the system under test, which is the requirement analysis. First of all, we have to know the system very well. And then, accordingly, after we know all the use scenarios and the corner cases and the behaviors which are observed by the users, then we design and define some test steps. We add some step by step test descriptions and scenarios. And then we execute them in either way, either manual ways or automated ways, we execute them. So if we are doing the automated way, then we should implement them first of all. We should develop the test code. And then we execute. And then finally we maintain. We do the continuous maintenance. So we can either maintain the test code itself, or we can manage the observations during we collect during the test executions. For example, if we find any bugs, then we can report them, or even the classification or the clustering of the bugs is another problem for the machine learning activities or algorithm. So, in each stage, starting from the requirement analysis until the continuous maintenance, we can somehow embrace and apply lots of different machine learning algorithms. So, let me start by the first one, which is the analyzing the system which will be under test and designing some relevant test cases. So, I want to start with a little and very short reminder about how the machine learning algorithms work. Actually, I can relate this to how we are working as human testers. So, if you have a product, you develop something, and if you hire me as a test engineer, when you ask me to test your product, my first question would be, okay, I can test your system, but first of all, please teach me this system, or let me learn this system. So what I can do is I can do some exploratory testing, or I can do some exploratory activities to figure out what kind of components there are in the system, or when I do some actions or transactions, or when I click the buttons on the pages, what happens? I will observe. I will learn the reactions or the responses from the system. So this is my learning stage. So for the machines, it is working in a very similar fashion. So first of all, this algorithm should learn how the system works, or how it should work. First of all, this should be learned, and then the training or the evaluation or the prediction stage starts. So let me go over a concrete example. I put a example data here, which can be used in a library API. If we have an application protocol interface for our library, which means I have lots of different books in my library, right? So I can do some queries over my APIs. I can get the list of all the books or a unique book by passing the ID of the book. Or I can send some update queries. For example, every book entity has some attributes, like they have the ISBN numbers, they have the price, they have the publish year, they have lots of different information stored on different attributes on the entity. So I can update these fields as well. For example, if there's inflation, then I can increase the price of the book, right? I will update or I will send an update request. So after each request, we can observe what kind of responses are coming. For example, if these APIs or the endpoints are the authenticated ones, and if I send a request without any authenticated token, then what I will have is maybe for all one response code, which is the authentication or authorization error, or 403 or any other related response code. So after learning this kind of patterns, okay, so for another endpoint, if I again send another request, maybe without a token or with a token which is not valid or expired, Then, according to my learned past experiences, I will expect a response code, which will be either 401 or 403 or any other relevant response code. So in this way, machine can generate some similar test cases. It can inject some different tokens, maybe in a bat format, in an expired format, or even it can add some different values to improve my coverage. For example, if it learns already the ISBN number should be a string value in a specific format, like after first character there should be a dash character and there should be three more digits and another dash. This is the expected format, let's say. So what the machine algorithm can do is it can inject some wrong formatted data intentionally. So this will be my negative test case, which is generated by the machine learning algorithm. So in this case, I will already be improving my test coverage and generating some test cases. And after I define and design my test cases or the test scenarios, what I will do next is to implement my test code if I will do the automated test execution. So there are some algorithms which are based on NLP, the language processing algorithms, and in which language you are using, regardless, it can be converted into some code. For example, even if you type in the natural language that you are using, for example, let's proceed with English. If I type navigate to this URL and click this button which was under the label submit your form, let's say this string. And eventually, you should expect the page is navigated to the next page, or the system should be navigated to the next page, and you should see the result of your query. Let's say I put this input string in my natural language, and then it can be automatically converted to the test code already. So this will facilitate a lot my manual efforts. And another example, uh, rather than using the traditional locators or the selectors, we can use the visual recognition algorithms. For example, our problem is to locate the elements on the pages, right? So rather than using the XPath or the complex and complicated class paths, what if we try to locate them visually? For example, if we are testing an online shopping site, most probably we will have some online shopping cart icons, right? Which are like a image of a basket or something like that. So when I explore the other online shopping sites, most probably I will see is the basket icon is empty when I did not include any items. But whenever I start adding some items into the basket, it will be the icon with some items inside. The image will be a different one. So if I somehow teach this to my algorithm, then when I start designing my test steps, it will already understand what I'm trying to do. For example, when I add some items into my cart, then it will already expect the icon will be updated with a new image or with a new icon. So the relevant code can be automatically generated in the background. So this kind of test code generation can be done by machine learning algorithms. So I'm putting some examples here just as a reference. So most of them are uh, public and open, so you can just go and try. So there are some open repositories that we can use for our activities. And I have some example commercial tools as well, but I don't have any commercial concern. But just for example, I'm sharing some tools and algorithms which are already using the machine learning algorithms in their products. So the next stage after implementing the test code is executing them. So what we can do while we are executing test cases, what kind of machine learning approaches that we can apply? For example, again, going over on a concrete example, let's think that the execution duration is important for me. I have a limited testing window. So I want to keep average execution duration per each test case in a limited time. So what I can do is by iterating lots of different executions, I can observe what is the expected or what is the actual execution duration in each execution. So I can observe in the first execution it was, let's say, 30 seconds. And in the second execution it was 35 seconds, let's say. In the third one it was 25 seconds. So what I can learn is, for this test case, the average execution duration is 30 seconds. This is what I can learn from the past observations. So in any of the future executions, if the execution is not around 30 seconds, but if it is like 3 minutes, 4 minutes, then I can understand there is something wrong. It is not in the expected pattern. So the machine learning algorithm can already notify me, please go and check this execution. Maybe there is something wrong in this execution because this was not aligned with my past examples. It is not in my expected pattern. So please go and check. Maybe one of the servers or one of the components did not respond in time. Maybe something happened in the backend services. So this kind of automated notifications I can have. So rather than going through all the executions one by one individually and manually, I can already be notified in a smart way by the machine learning algorithms. So similarly, we can observe all the executions and we can collect lots of different metrics. And eventually, if we come up with a certain pattern, then we can apply this in the future or in the next executions to collect if those executions are aligned with the expected ones or not. And the last part, the last ring in the whole chain is the continuous maintenance after doing the executions. So, in terms of maintenance, what can we do with embracing the machine learning algorithms in our activities? For example, we can do the code reviews with the help of machine learning algorithms. If we somehow can teach some best practices, or in the meantime, some anti patterns that we should avoid to the machines, then they can help us with the code reviews. For example, if I can teach machines that having some embedded numbers, having some magical numbers in the code is not a good practice. It is an anti pattern that I should avoid. If it learns it, and then when I let it run to do the code review, whenever it sees some magical numbers in the code, it will notify me. This is something you try to teach me, and now I see there are some embedded numbers which I don't understand the meaning. So it is a magical number. So please go and fix it. So these kind of code reviews can be done. Or another example is we can manage the bugs. Because when we are talking about bugs, it is a classification problem. Because why we are doing the bug triage after reporting the bugs, right? We are trying to assign these bugs to different people and we are trying to prioritize them. We are assigning some different criticality levels. For example, some of them will be really severe and urgent, and we should immediately add into our sprint backlogs. But otherwise, if they are not high priority or high severity, then we can let it stay in the backlogs. So we can postpone the solution. So doing the correct triage is very important. If we are assigning to a wrong prioritization, then maybe we will be postponing the bug fix normally, which should be immediately fixed. Or otherwise, if we are prioritizing the wrong tasks normally which may be postponed, then we will be blocking some other tasks which are more urgent. So the triage is very important, and doing this is very consistent. Doing this in a consistent way is very important. But let's think about this. As a human tester, when I'm reporting a bug, generally I'm not checking the other bugs reported by other people, right? But if I observe this, maybe I will observe some inconsistencies. For example, this bug for me is a, let's say, priority 2. But for another person, it's not priority 2, but it's priority 4. So who will decide this? It's a subjective issue. But if we let the machine observe all the data, because if we are talking about big data, it is very difficult problem for human beings, but the machines can deal with it. So we can do bug classification, the bug triage, assigning the priorities or assigning to the correct people is very important, and we can do by thanks to machine learning algorithms in a more consistent way. This is what I tried to do in one of my actual projects. So I had some different priority levels, and by trying to learn from reading the description of the box, and then by some trying some different approaches, like it is called bag of words. It is trying to count the frequency of different keywords, and it is trying to reveal some hidden patterns underlying the box. And then eventually, when it reveals some patterns, then for the upcoming bugs, for example, when a new bug is reported, it is trying to predict the priority level. So it will help us a lot to improve the efficiency or the consistency, we can say. So I'm wrapping up. We went over lots of different changes and updates that we are performing in our testing activities, because the software testing is being evolved a lot. When we think about what we were doing many years ago, it is not the same thing that we are doing now. What we are doing has changed a lot. And in the meantime, how we are doing is also changed and has also updated by us, by our initiatives, and by our improvements. But after each of them, we have some new challenges, and the difficulties and the problems that we have to cope with never ends. We have always some new improvement rooms, and maybe recently what we can do is maybe even more embrace the machine learning algorithms in our testing activities, and we can succeed more efficiency and reduce the manual efforts and reduce the maintenance efforts, and maybe we can use and improve the reusability, flexibility, scalability, and consistency by thanks to these machine learning algorithms. So thanks a lot for listening, and I hope we have a little bit time to go over the questions if you have any.
Thank you, Mesut. I put two questions in the chat. One
Okay.
is, how can QA convince the management to be involved in the development phase, and how much should they be involved?
I think they should be involved as much as possible, because yeah, this is true. Because even if we are not directly executing test cases, because quality assurance is not only testing, and testing is not only executing test cases. So we should see the product from a wider perspective. We are the advocates of the customers, so there's a lot of things that we can improve. So even if we are not starting the execution of the test cases, we can still give some feedback. We can already, whenever the design or the development activities start, we can already give some feedback. For example, we can think about the usability of the product or the feature, or we can even think about the testability of the feature or the requirement. So it is important to be involved in the early stages. So I think we should be involved in all of the activities in the development phase. So we should be involved as much as possible. And how we convince the management? We can do lots of different presentations. We can share what we feel, and if we are trying to encourage QA involvement, what is the reason? Why are we trying to encourage this? If we somehow explain this, I'm sure everyone will be on the same page, and everyone will have the quality mindset. I think in that case, it will be easier to convince them.
Absolutely. We got about a couple of minutes left and one final question. In your opinion, how can we as QAs shift the mindset from waterfall to agile with the challenges in agile approach, like quick interactions and short releases? And how can we do it effectively and help the team?
Yeah, I think it is a little bit related to the first one, but
Yeah.
in Agile, the main difference with the waterfall is, in waterfall, I remember we had hundreds of pages of requirement documents, and we were analyzing these kind of requirements for months. Like first 6 months was only the requirement analysis stage, but in Agile, the main difference is we don't have that phase again. But instead, what we have is we want to quickly go to production. And what is the reason? To have more interaction with the users. If they already have some observations, or already have an idea about the usability or the feasibility of these features, then we will be already able to collect this feedback. So I think the main key point in which we can contribute or help the team is we should encourage more a customer or the end user interaction, and we should communicate to them a lot, I guess.
Yeah, yeah, I absolutely agree with that. We're going to round it off here, everyone. Thank you so much, Mesut. Um, I can see a lot of your socials on screen. If you still have any questions, hit him up on LinkedIn or on
Absolutely.
Twitter or through his website. We're going to take a small break of 5 minutes and we'll see you back on the leadership track in a bit. Thank you.
Thank you.